There we go. So let's look at the example that's in the book. Example 2 says solve 3 times x plus 2 less than 8. So here when I look at it, I say, oh, there, I've got a parenthesis. So of course I've got to get rid of this parenthesis first because we have the order of operations. So we multiply 3 times x plus 2, which means we take 3 times x, which gives us the 3x. And then we take 3 and we multiply it by 2, which gives us 6. So we get 3x plus 6 is less than 8. Then we subtract 6 from both sides. And these two 6's cancel out, and 8 minus 6 is 2. So we get 3x is less than 2. Then we divide both sides by 3. Because 3 is a positive number, nothing changes here. So these 3's cancel. We get x is less than 2 over 3. So that's our answer, which is similar to what you just did. And then what do? We come over here and we say all numbers less than 2 over 3 are the answer. So at 2 over 3, we put parentheses, which means it's not included, or you can put an open circle, depending on what the problem is giving you. So you could have also used an open circle and gone this way. So because it does not contain 2 over 3, you use these parentheses over here, okay? If you had less than or equal to, then you would use a bracket. But this one, because it's strictly less than, then you use this parentheses. Okay, so parentheses is used whenever you have strict inequality, which means you don't have an equal sign underneath it. Now, we're going to solve compound inequalities. So what's a compound inequality? It means that whatever you have is bounded on both sides. You have conditions on both sides. So like this one says 3x minus 7. This one says 3x minus 7, right, is at the same time greater than 5 and less than or equal to 8. So what this is really saying is 3x minus 7 is greater than 5 and at the same time 3x minus 7 is less than or equal to 8. So it's saying find all the numbers that satisfy both of these conditions. They have to be greater than 5 and at the same time less than or equal to 8. And this one, because there are no x's on the right-hand side or the left-hand side, what we can actually do is we can just do all the work at the same time. So this is a compound inequality. One of our options is doing all the work at the same time because there are no x's on the left or the right. So what do? We just say whatever we do to all 3 sides of this inequality. So I've got 3x minus 7 less than or equal to 8 greater than 5. So the first thing I need to get rid of is this negative 7. And the way to get rid of negative 7, I did it again. I think that I'm on the pen and I'm not. Sorry about that. So I say, okay, what do I need to get rid of first? It's this negative 7. So to get rid of that, we add 7. And look over here, you add 7 to all 3 sides, the left-hand side, the middle part, and the right-hand side. So here I get 5 plus 7 is 12. 3x minus 7 plus 7, these two cancel each other out. We just get 3x. And 8 plus 7 is 15. So my 3x is between 12 and 15. That means that now if I just want x by itself, I need to divide by 3. And again, you do it to all 3 sides. So 12 divided by 3 is 4. 3x divided by 3 is just x. And 15 over 3 is 5. So this is my answer. Then we just go and we draw it. So we say x has to be greater, strictly greater than 4, and less than or equal to 5. So here we have parentheses at 4, brackets at 5, and everything in between. So our answer is the half open interval 4 to 5, where it's closed at 5 and open at 4. All right, I'm going to do an example on the board here so that I can go a little bit slower. Oh. And I'll do one more example, and then we'll do a compound inequality with an x in it too. So let's do this one first. One similar to the one that we just did over there. 2x plus 2. This is number 34 in your textbook.